Hey friends, welcome to my channel. Let's have a look at problem 1034, coloring a border. This problem actually continues from problem 733, flood fill. This type of problem actually can be all solved by sort of traversal, right? You can use different formats, like in the previous video for this problem 733, we used recursion, and here in this video we do this problem still based on traversal, and in order to do a better or deeper analysis, we're going to use both iterative format and recursive format. So with that said, let's first look at the problem. So here we are given an m by n integer matrix called grid and 3 integers, row, column, and color. So each value in the grid represents the color of the grid square at that location. So two squares belong to the same connected component if they have the same color and are next to each other in any of the 4 directions. The border of a connected component is all the squares in the connected component that are either 4 directly adjacent to a square not in the component or on the boundary of the grid. So we should color the border of the connected component that contains the square grid at position row and column with color given by this color variable. So we need to return the final grid, right? So here are 3 examples. So these examples are very easy to interpret, so we will not go into details here. The constraints are the following. First, the number of rows and number of columns are given by m and n respectively. So these 2 numbers are bounded in between 1 and 50, both inclusive. And the elements in the grid and the color itself is bounded in between 1 and 1000, both inclusive. And originally, row and column are inbound. So with that said, we are ready to do the analysis and share our plan. So in this video, we're going to write 2 formats of solution. So first, I'm going to write a traversal-based solution using iterative format. We just translate the main statement into code. For example, here requires us to find connected component, and here need us to find the boundary and make the change, right? So now let's look at the coding. So the first one I'm going to write in iterative format. For this, I'm going to use depth first search. So let's write in step by step. So step 0. So first we make some preparation, right? So we can get this m n just for convenience, right? So we have length grid and length grid 0. This is a very standard or routine. Next, we want to write a DFS utility function, so hyperfunction. So here I'm in iterative format. So for this, let's write a function called get component, right? So we're going to accept a initial position and a color variable. Let's use just the formally. This does not matter. And then what we are going to do is to get the connect component starting from this position and have this color, right? So here we can use a set to represent the connected component, right? And then what we are going to do, we initialize a list. So I'm going to use this list as a stack. So the head will be the tail, right? And then we just iterate. Well, as then we get xy in equals s pop, right? And then we are going to edit this guy to visit it. And because currently we are visiting this cell, and later it will be visited. And then we look at the neighbor. So let's write x1, y1 in. So I'm going to use a set, right? x minus 1 y, and x plus 1 y, and x y minus 1, x y plus 1, right? Then we are going to do some standard checkup. So we are going to check if the new neighbor x1, y1, so it's inbound and it's not visited and have the same color as the initial position. That is, if 0 less than or equal to x1 less than m, and 0 less or equal than y1 less than n. So this checks makes sure x1 and y1 are inbound, and also we want to make sure x1, y1 are not invisited. Then what we want to check, let's also put parentheses just to make the logic clear. And we want to check grid. So x1 and y1 equals the original color, right? Notice that this is a local variable in for this function. This color might be different than this one, right? Then if this new position x1, y1 first is inbound and not visited yet, and also have the same color as the source, so we're going to add this guy to the top of the stack. And then what we are going to do is to return, maybe right here, return visited. So this set visited is the corresponding connected component containing this source and with the color given at the source. So this is the step 1. Next, let's look at step 2. So we get the boundary, right? Set the boundary cells. So here, boundary in the recursive sense, it means the boundary of the connected component, right? Set this to the given color, right? So first, let's get the cluster of connected component. That is, we call this function get component. So this is at row and column, and the color will be grid row color, right? So this will give us the coordinates of cells in the cluster, in the desired cluster. So here, in order to not mess with the original grid, let me make a copy of this one, grid copy. Then what we are going to do, so we are going to iterate, right, for RC in cluster. So we want to tell if this RC is a boundary. So this is actually very easy to check. So one is if RC is already in the boundary of the grid, so it's a boundary for sure for this component. So if R in 0, m minus 1, or C in 0, m minus 1. So this whole condition checks if RC is a boundary cell in the original cell. If this is the case, it means it's also a boundary of the connected component. So we're going to set result RC to color. So here the color will be this one, right? And then this is the one check. Another check is if there is a neighbor of this one is not in the cluster, right? Then it's boundary. This is just using this very definition, right? Or on the boundary, yeah, not in the component, right? So now let's write that in a code format. So here let's write for xy in I'm going to use a set again because we are using tuple, right? So that is r minus 1 c, r plus 1 c, and x r c plus 1, r c minus 1. And because we have checked this one, right? All these 4 points will be inbound, right? After this if check. And then if any of these are not in the cluster, because this is very easy to check because it's a set, and then we just need to do the set because it's already a boundary cell. So if let's check if xy are not in cluster, right? And then we can just set result rc equals color. Then we break. We don't need to check anymore, right? And then we are ready to do the return. So we return the result state. This code forms a solution format to this problem. So before we move forward, let's first do a check. Get a component is not defined. Let me copy this function. Signature, because there may be some mistake. So component, so it's int component. Let's see if this is better. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. This is one solution format. So let me copy this part, and then I'll change the first solution format to be solution v1. So now let's write another solution format. Here I'm going to use recursive format. In other words, we are going to use recursion. Essentially the same idea, but we write in a recursive format. So step 0 will be the same. We get m and n. In other words, the number of rows and number of columns. And then we want to write a DFS. So we write step 1 DFS hyper function in recursion, right? For this, let me first initialize set. So this is in parallel to this one, right? So we write it here, right? So we get this set, and then we are going to write a traversal function to do the job for us. So traverse. So here start from RC and a given color. The color is the color for at this position, right? And then first I'm going to do is to check if r less than 0 or r greater than or equal to m, or c less we just actually just do not need this things. Any of them will be fine. Will mean that the position is out of bound. If c less than 0 or c greater than or equal to n. So this is the out of bound condition. So we're going to return. We do nothing. Otherwise, so because we already have this set, we want to check if grid RC equals the given color, right? So originally we want to set color equals RC to include the source at least. And then we want to check RC not visited, right? So if it's not visited, what do? We do visited add, right? Then add this RC. And then we're going to do traversal for the 4 neighbors. That is, let's copy this one. Let's do up and down. Let's copy again. Left. Let's copy this one. Right. And then that's it. So this is the hyperfunction. So as we call this function, it's going to modify this visitor set to get the corresponding cluster or connected component. So this is step 1. Now let's look at step 2. So exactly parallel to above, right? So what we're going to do is to call this function. Let me still call it cluster, right? So cluster. So above is get component. Now let's do not this. So we do traversal, right? Traverse R, so not R, and row, column, and grid, row, column, right? So as we call this function, this state of this visitor set will be changed, but the visitor set, the visited actually is exactly corresponding to the cluster here. So let me maybe change this. Let me just maybe introduce a variable. Let's call it cluster equals visited, so that we don't need to type anymore. So we just copy this part, right? So here is set the color. This is the step 3, right? We didn't change anything, so we can make a copy, and then we traverse the cluster, and then if it's boundary, so we set it. So this actually forms another format, but here we used recursion. So now let's do a check again. Oh, syntax error. Let's see. If grid. Let's see, where is it? If grid color and not invisited. So here we forgot this one. Now let's check. That's a problem. Okay, so it passes. I don't know why it takes such a long time. So now let's look at the generic case. Oh yeah, it passes all the cases. So if you like, because here we're using recursion, you can use some cache, for example. Cache here, use a decorator. Let's check again. It passes all the cases. Anyway, this is not necessary for this problem set here. I guess that's about it for this problem. So basically, the structure of this problem or this coding solutions are the following. We identify the connect component, and then we do the corresponding change in color. For the first one, so if we want to get connect component, typically we can do two methods. So one is using traversal, like here, right? And also actually we can use unified or disjoint set abstract data type. Actually it deserves a try, so if you have time. And then for writing the traversal solutions, then we can actually use iterative format like here, or we can use recursive format. But if we make a comparison of these two code formats for the two solutions, so they are actually the same solution. So just in different representations, I would say. With that said, I guess that's about it for this video. If you found this explanation of use, you're welcome to share with your friends. Thank you.